So this is the ramp going towards the VIP toilets, or the ventilated improved twin pit toilets. Now what you see here is actually the ramp, and you will notice that it's made in two parts with intermediately a horizontal platform. The slope of this platform is 12.5%, and this is about the maximum that you can get for a wheelchair user to be pushing himself up. Now you have to be already a quite good, strong wheelchair user to be actually to use this kind of slope. 12.5% is normally already to be used with somebody who is helping you to do the trick. Also very important is that wherever you are on the slope, that you can actually turn the wheelchair completely. Now obviously I'm not a very used wheelchair user, but you can see where the risk is that you have to be able to brake, and again here the horizontal platform helps us to be able to turn the wheelchair completely. Now once arrived at the toilet, of course there has to be a good access for the wheelchair user. Okay, once the wheelchair user has turned his chair, the question is now to slide over from his chair towards a seat. So obviously he's going to open the seat itself. We'll remove this, put it aside, and then the whole idea is that he can actually slide over. So here you can actually see that this sidebar actually will help the patient to slide from his chair over to the seat and then backwards. For a toilet for handicapped people, it is very important to have a sink inside, because as people do not really control their bowel system anymore, very often they have small accidents, and therefore it is essential that they can do some hygiene within the cubicle itself, within the cabin. If somebody would be in here with a broken leg, then actually the whole leg should be sticking outside of the door, which for privacy reasons is obviously not permitted. Therefore, in such toilets, it might be a better idea to have such a system here, where actually the hole, and you have a lot of room in front of your leg just to be able to squat down, or preferably, if you have a broken leg, that there is a seat that actually people can sit down. Again, very important is that people have something to hold them onto, and they can lift themselves again to come to a right position. Here we have different examples of honeycombed walls. The way the honeycomb wall is made here is with cement blocks. The advantage of working with these kind of blocks is that you can build your wall extremely fast. However, as you can see, the openings and therefore the actual surface you're going to have for infiltrating the water or the liquids is very, very small. Now you could try to open the gaps more than that, but then of course there is the difficulty and the danger that a lot of the outside earth of the underground will just start to fall in, and therefore that the pit would start to collapse. This opens up a lot more holes, and therefore the infiltration capacity of such a wall is a lot bigger than what with the cement wall we have seen before. However, this wall is not very strong, because the surface where the bricks are actually hitting each other with some cement mortar is very, very fine. So this will not resist the pressure of the outside earth trying to push the wall inwards, and therefore it would lead to collapse. Here again we work with normal bricks, so they are a lot smaller than cement blocks, and therefore the infiltration capacity will be potentially higher than with cement blocks, because we can have a lot more openings. However, in comparison to putting the bricks of the same size lengthwise, is that here there is a lot more overlap in between the bricks, and therefore this is a more solid wall. However, now to resist still the pressure, it will be very necessary here to put 2 layers of bricks next to each other, and you have to make sure that all these holes are actually very well aligned. Otherwise there will be no infiltration possible whatsoever.